Hi, I'm Larry Swanke, Director of Azure Services for Catapult Systems.
I'm Jay Douglas, Solution Architect, focusing on Azure technologies. If you have any questions, comments, or just want to talk about today's topic, click the button below and you can put time on our calendar right now to have a discussion. Welcome to the Azure Bootcamp. This week, we're talking about application containerization. What are containers? I tend to think of containers as a cross between a virtual machine and an installation package. It has everything you need in one concise package to run the program, configure it, all its dependencies and its assemblies. It's based on this technology called Docker. Docker was first kind of implemented within Linux operating systems to provide kind of controlled namespacing abstraction from the operating system kernel. What this means is everything had its own memory space, its own processing space, and its own address space. This really allowed kind of applications to be portable and run across different distributions. It's evolved a lot in the past few years. Now it's supporting Windows, Linux, variety of different application development technologies and platforms. In addition to that, a lot of off-the-shelf applications are coming as Docker images, so you can run them on your machine. So think of a way to kind of abstract, be able to port your application between different operating systems, different platforms with no underlying changes. This is all because of containers and Dockers. What does it mean for Azure and kind of why is this in Azure Bootcamp? Well, now Azure kind of has a first-class offering for containers through something called Windows Server Containers. You have sort of this traditional sort of host user mode that currently exists with the Docker image, but now it runs on top of the Windows kernel. You can now do Windows Server Containers. And what this means is traditionally we were limited to what would run on a Linux operating system. So .NET Core worked great, Java virtual machines, those types of things, Python, whatever you get to run natively on Linux worked well, but not necessarily IIS packages or .NET Standard. So now what they're offering here now is .NET Standard containers on top of Docker. And then in addition to that, there's a more kind of traditional Linux containers as well, all running on top of the hypervisor. This is available inside your data center and inside of Azure as well. So kind of where do developers spend most of their time? It's anywhere from kind of like taking care and sustaining existing code, whether you're fixing things or, adding new features and those types of things. It's all about kind of, keeping the lights on with an existing application. What we want them to do is build new applications and new features and expand that capability. Same with the operations team. Same guy here, kind of miserable, right? They're maintaining this existing application, keeping the lights on. I think there's a metric out there, like 74% of IT spend goes to operations and maintenance. It's part of this, maintaining these applications, dealing with deployment, trying to debug, these applications in production, and most folks will know this is a very difficult thing to do. Rarely are they kind of, rolling out that new application that is very necessary for businesses. Some interesting things to think about with containers. Folks that are using containers for their primary platform, they're really starting to see those systems become more available. When there's issues, the mean time of resolution is a lot easier because of the isolation and the portability of it. It's able to scale. Instead of spinning up new VMs and to reach that scalability and performance, you're now just spinning up additional containers. And superset of that, you can spin up more VMs under the scenes to support those new containers, but you're able to scale up quicker with the containers and much more agile. So what's happening is developers configure these containers on their machine, and this same configuration, the same container and image works in production. So it's much more easier to deploy software, and it's happening much more frequently. So instead of deploying software in the sense of months, quarters, now you're deploying software in the sense of hours, days, weeks, whatever makes sense for your organization. All right, so you want to use containers today, you can. And there's a really straightforward path whether you're using .NET Core, .NET Standard on Windows, or Java, or whatever, Python, whatever your platform is, you can start using containers now. First, you kind of take your existing application, all its assemblies, You can create an image and a definition of that using Docker EE or Visual Studio or whatever your IDE of choice is. You use Notepad if you want to. Then you kind of you take that container and you basically test it in the cloud, right? And you can do that through modern methodologies using DevOps, VSTS, Jenkins, whatnot. They all have capability to kind of, ingest this information, build the image, and publish it. Once you kind of have those 4 first steps laid out with your application modernization, you start looking at modernizing with microservices. And that's breaking out certain components of your application into separate packages that are completely independent of its main implementation. The first thing we see that happen with web apps is taking out kind of those data access APIs and moving them into their own package and then having the UI separately. What that really allows you to do is to be able to scale up the UI and API separately within their own containers. Very powerful. When kind of looking at what application you're going to use, first OS dependency, you probably want to avoid systems that are using very specific Windows hooks like, COM or those types of things, or things that really need specific instructions within the Linux kernel. So really, most modern web applications don't require that, but really look at how tight those are from a networking, processing, or APIs aspect. Application state. Where does it reside? Are you keeping it in process, or is that being stored on disk, or is that, with some sort of state server, which is how most modern applications are. If it's in process, containers may not work. You might want to look about, how to manage your state there. And, how are you going to scale this application? Do you scale behind a load balancer or whatnot? Kind of consider all these options. So Azure offers, a lot of answers to containerization. I think, first they have like kind of the native container management orchestration that is out there that folks are used to. Kubernetes is in there, definitely kind of a first-class offering. They have sort of kind of a managed containerization, the Azure Container Services. Very powerful to help manage your containers. You definitely want to look at that. This is also available in Azure and Azure Stack as well. And then, container-based paths. Where are they using containers within their path solutions? Some things we learned, kind of helping customers modernize their application. You want to look at your image size. Image is kind of like all your assemblies. The bigger, the more complex it is. It takes longer to build, deploy, stand up and provision, and scale out. So the smaller you can make those images, the better. Automate your builds and deployments of these. There's a lot of tools out there. This is definitely born in the age of automation and DevOps, and there's a ton of capabilities. Always automate and deploy and build your Docker images. Map your volumes. So these are basically like, exposed endpoints that the container has. And they're usually for like data, configuration, temporary, those types of things. Make sure those are mapped to your operating system, even if you think they won't be used. It'll help manage state and make sure it recovers well. When you're looking at your Docker cluster, where you use Swarm, DCOS, or Kubernetes, figure out, how much it's going to cost to run. Do that TCO up front so you know what to expect, because they can run away from you rather quick. Understand your performance requirements and access requirements. Is your underlying hardware going to support it? Is virtualization and containerization going to slow that down? And add applications at scale, use an orchestration platform. Back to DCOS, Kubernetes, Swarm, those types of things. That'll really help improve your containerization capability.